Hello everybody and welcome in this video. So today we will be making a solution for the project number 2 of the last session or the last lesson, which is the lesson number 5. Okay, and we will be making a program to calculate the determinant of a matrix. Right. So because the program is a little bit hard and a little bit difficult and contain much of things, I thought that making a video and making a program from zero will take a lot of time. This is why I tried to make the program, and I will be just explaining how I made it, and I will be explaining all the things in the program. Okay, so I have here 4 matrices for the test, and I have here the program presented by one function called determinant. And you can see there are 2 other functions, but they are inside this function, so those are called nested functions, right? So we can call them inside the function. So for example, this is determinant, and we will call calculator, which is a function inside determinant. So why I did all of that, we will see this soon. Okay, so let's try to take this simple matrix here, So if we want to make or to calculate the determinant, as you know, we will, for example, take this line. We will make signs for the factors. So this will have plus, -1, plus, -1, plus, -1, etc. So we will have true, okay, true. We will take all this column off and this line off. So we will have just a matrix made by these 4 values. So we will have 2 multiplied by the determinant of this matrix plus, okay, -1 multiplied by the determinant of the matrix made by those 4 numbers, and the same thing for the 3. So this is the logic that we have to adopt to make the program, right? So the first thing, I had to make a redefinition for the matrix. So the redef matrix is a function that can give signs to the factors. So this will have plus, -1, plus, etc. If I have a number here, -1, etc. This -1 plus, etc. Right? But as you know, when we do true, for example, multiplied by the matrix made by those 4 numbers have to be with their initial values. Okay, so we will have 0, 2, 0, and -2, and not the redefined matrix. Okay, so as I said here, so determinant R matrix. So we will put the matrix here, then we will make a variable, and I will give it 0. Then I will call calculator R matrix. So as you can see here, this calculator have 2 parameters, but I give just 1 because I initialize this value by 1. So if I put, for example, here a factor and I give it a value, the factor inside the calculator would take the value that I give here. So if I didn't give a value, it will just take the initial value, right? So I have done also what we call the not local, just to say within this function, if I modify the value of this state, so I'm modifying the whole value of the mother function. Okay, so I make a new function, redef matrix copy deep copy matrix, right? So copy deep copy, just to avoid altering this matrix, okay, because I will need it. As I said, the determinant will be calculated by the real matrix, not the matrix that I modified by adding signs to the matrix. Okay, so I made the matrix by redef matrix. Okay, as you know, the -1 will be power e plus g, which are the iterators for line and column, and multiplied, of course, by the factor of the matrix eg. Then I will return the whole matrix. So if Okay, we will just avoid this for this time. So else, if the length of the matrix is superior than 2, for example here we have 3, right? So we have 3, then we will make a v pointer that will point or that will take the values from 0 to length matrix minus 1, okay, just to point on the column. So the first column is column 0, the second column, and the third column, right? Then I will try to make submatrices, right, and sublines. So the first thing, I will take the first column, okay, so I will take the first column, so this is v.0, and then I will take line and index and I line from zip, enumerate matrix, and I matrix. So this is the real matrix, sorry, and this is the redefined matrix, okay. So this matrix and this matrix, and then I have index equals 0, continue, because when I point on this value I have to delete this whole line. So if line is 0, I will just continue to the second line, right? So continue when line equal 1, I have to ignore the element of the column where I point. So I'm pointing on the first column, meaning I will take this value, so I will ignore this value and this value. So if element in the first column or in the column when viewpoint is pointing, index is equal to viewpoint, I will continue, right? And then I will be making lines by those elements. So in this case I will make a first line made by 0 and 1. So this is my returned line. Then I will just store or append this line to a submatrix, and so on till I make the first matrix, which is 0, 12, 0, minus 12. Okay. Then what I have to make is to call again calculator, right? So I call calculator here, but this time with L factor. What is L factor? Is factor the initial factor here. We did nothing here, so we have 1 multiplied by what? By matrix 0 v pointer, line 0 and v pointer, which is 0. Okay, so I'm pointing on number 2. Right. So this is for the L factor. Then the matrix will be this time submatrix, right? So the second thing, when I will call the calculator, I will enter here, because the submatrix is equal to 2, the length of the submatrix, or the size of the submatrix, right? So when I enter here, I will take the 2 lines, right, of the real matrix, not the redefined one, but the factors are made by the matrices redefined by the redefined matrices. Okay, is this making sense? Right. So after this I will calculate the subdeterminant, which is factor, right? The factor this time is factor multiplied by L factor, okay? And of course line 0 multiply line 1 multiply line 1 0 multiplied by line 2 1, okay, minus etc. So line, so I will be taking this value, I will multiply it by this, and then I will subtract this value multiplied by this value. Okay, so this is what I want to do, and then I will just add this value to the 0, and finally I will end. So when I will end this, I will be just exciting this function. So I will back to the mother function, right? And this time the v pointer will be equal to 1, right? Okay, so when v pointer equal to 1, this means I will be taking this time this 1 multiplied by the matrix made by those 4 values, but the one here will be minus 1 because plus, and here we will have the minus. Okay, so of course with the same manner I will make this matrix, then I will go here and calculate the subdeterminant and I will edit it, and with the same manner v pointer will be equal to 3 and I will be making a matrix with these 4 variables, right? And after that I will calculate the determinant. Okay, and after this I will exit the called function or the subcalled function. I will back to the real or the mother function, right? And in this mother function I will just end the for because we finished the range, so I will just pass. So this is a function, okay? So after this for there is nothing, so I will just exit this line. So after exiting this line I will just return the determinant. This is a little bit hard because we have recursive functions, so I just try to explain a little bit with just a matrix of size 3, right? Because in this time we will just call the function and this function will call just one time another function, but with this big matrix we will have 4 or maybe 5 calling, okay? 5 calling at the same time. So the last function called, when it end, we will back to the function that comes before the function, and then so on till I come back to the mother function, the function called by the big function here. And after finishing this function again I will just end the whole process and return the determinant. So this is the key or the secret of recursive functions, okay? And let's try to calculate the determinant of some of those matrices. I verified the results by a website that calculated determinant. I compared my results with the results of the website, I'm sorry, and I had good results. So my results fit with the results of the website, I'm sorry, which means that the program is running well. Okay, so let's start it. Print determinant. Yes, print determinant. So I have -1. So the determinant of this whole matrix is just -1. Okay, so for example of test here I will have a big number. So you can just guys take the program and test it and you can get good results. Okay, so guys, this is all for this video. I hope you understood well how we can make a determinant with nested functions in Python. So if you have any question, if you have any other questions, maybe something that I didn't explain well, okay, you can just put it all in the comment, and just please don't forget like and subscribe. So see you next time.